Maynard F factor. When do we use the Maynard F factor? We use this for extended SSD treatments only. This is when we need to recalculate the percent depth dose for extended SSD treatments. What do we do with this factor? We need to correct for the percent depth dose at the extended distance. We use this formula to correct for the change in distance and then multiply this factor by our old percent depth dose and then put this into our new monitor unit calculation. What are the relationships? If we increase our SSD, we increase the percent depth dose. If we increase the percent depth dose, we will see an increase in monitor unit, obviously because the distance increases. So the increase in percent depth dose means an increase in calculation dose. So you need to ask yourself, does this make sense? If I get farther away, should I be increasing the monitor unit and increasing the dose that I give to the patient? And I think this always goes back to the inverse square law. When you're talking about distances, obviously that's applied in this principle. You're getting farther away from the source, and because you still need to treat the patient to a certain depth, you're going to have to apply more dose. You're going to have to give more monitor units to the patient to get that dose to the certain depth in the patient. So on the exam, if we know we're going to have an extended SSD and we know the percent depth dose should get higher, what answers are you going to cross out on the exam for choices? If you know you're going to expect to see a higher percent depth dose because of an extended SSD, you know to cross out the smaller percent depth dose numbers for choices. So do that right off the bat if that's what the question is asking you. That way you know if you mess up your formula, then you aren't going to pick one of those wrong answers. On a calculation for an exam or in a clinic, what would you expect to happen to the monitor units when compared to 100 SSD? You're going to expect to see your monitor units get higher for an extended SSD. We talked about the monitor unit increase because you're getting farther away from the source. So whether it's a clinical application or a calculation, when you have a regular 100 SSD calculation and now you're going to go to an extended SSD, you should see an increase in monitor units. Here's an example using our formula again. Take a cobalt machine, 10 cm depth, 80 cm SSD. Your percent depth dose is 59.2. What is the percent depth dose for 100 SSD? They're going to assume that you know the Dmax for cobalt machine is 0.5. It's always 0.5. It's a given, so they're probably not going to give that to you. Assume that you know that. And go ahead and set up your formula. Put your numbers in. Remember that 80 cm SSD is standard for a cobalt machine. So the 100 SSD here is an extended SSD problem. So when we put those numbers in, we get a Maynard F factor of 1.043. Now once you get that factor, you have to remember you need to multiply that now by your old percent depth dose in order to get your new percent depth dose. Now you should have 61.7. Now you have that new percent depth dose. That's what you're going to go in and put into your monitor unit calculation as your new percent depth dose. And then you can go ahead and do your regular monitor unit calculation. You're going to expect to see a higher number of monitor units now for this calculation. So just remember when you're doing your problems or you see problems on an exam, right when they start talking about extended SSD treatments and they start talking about solving for percent depth dose, right off the bat, you know you're going to use the Maynard F formula to solve for percent depth dose changes.